Hi folks, I'm Tanmai. I'm the co-founder CEO at Hasura, and I'm going to talk to you a little bit today about strategies to automate caching with GraphQL.
Hi folks, I'm going to talk about approaches to automating data caching with GraphQL. I'm Tanmay, I'm the co-founder at Hasura. Hasura is a GraphQL engine, and a lot of our learnings on caching have been based on interactions with Hasura users and at building Hasura. Hasura gives you an instant real-time GraphQL API on Postgres, and other databases are coming soon. That means GraphQL queries, mutations, and subscriptions, which are secured with authorization rules. You can also bring in other services like GraphQL or REST services and connect them to get a unified GraphQL API. You can run Hasura as a Docker container on your own infrastructure or use Hasura Cloud. Hasura is open source. Check it out on GitHub. All right, onwards to caching. So query caching and data caching, right? So caching queries is the idea of caching the query execution plan so that whenever a new GraphQL query comes in, you don't have to figure out what to do. The server doesn't have to parse it, validate it, and figure out what to do every single time the same query, maybe with different variables, comes in. Caching data, on the other hand, is that you basically want to avoid hitting the upstream data source for queries that are expensive, and you want to reduce your load on the upstream, for example, database, right? So first, I'm going to talk a little bit about query caching, right? So query caching is fairly straightforward, or I mean, the way you would implement it is, so query caching is fairly straightforward. What you would do is for every incoming GraphQL query, you would normalize it, validate it, strip out fragments, dedupe fields and stuff like that. Then you can hash the GraphQL query and store the fact that this kind of normalized GraphQL query and the plan that is going to come, the sequence of execution, you can store that plan in a map. And then every time this GraphQL query comes in, you can fetch that from a cache, fetch the plan from a cache, and then run that plan, right? And you can use something like an LRU strategy to bound the size of the cache, right? And that's kind of how GraphQL query caching will work. The nice thing is that if you have something like an allow list, or your GraphQL client can support making a query using that hash directly, you won't even need to send a GraphQL query in the first place. You can check out approaches like with what GraphQL JIT and Fastify GraphQL are doing to understand different flavors of query caching and of optimizing execution plans for executing a GraphQL query. GraphQL query caching is a 10x win when you pair it with database query caching. And so databases, which provide a query language to query the database, also offer the same idea of being able to cache a query instead of parsing and figuring out how to run and execute that query for every new query that comes in. And these are often called prepared statements. So what you can do so one approach that works really well here is that instead of a pure resolver approach that you have with GraphQL, if you think about a pushdown approach where you take a part of the GraphQL query or maybe even the entire GraphQL query and you're able to compile that into a database query, what you can do is you can send the database the entire query, and that way what the database can do is it can cache that query plan as well, right? And these are called prepared statements. The nice thing here is that whenever this GraphQL query now comes in, what happens is that the GraphQL query, which has maybe query variables and session variables like the user ID or like the cookie or the resolved cookie, this information is processed by zooming the session variables and the query variables directly through to the database, right? Because what happens is the GraphQL query is not really processed. Only these variables are taken. The GraphQL query plan, the GraphQL query cache is looked up, and then you get the SQL query. And in fact, you don't even have the full SQL query. You can look up the SQL query identifier if you're using a SQL database. And then you can now query that database with that query ID, right? So in both places, that is your GraphQL server and your database server, the query is not being processed. Only the right variables are sent through from the client all the way to the database. The way this looks like would be you have a client, the client makes a GraphQL request to the server, right? So it sends a query ID and variables, or the query and the GraphQL server does a lookup, which then becomes a SQL query and variables if it's sent to Postgres. And then that JSON can be zoomed back to the client, right? If you don't need to enrich that JSON at the GraphQL server again, you can actually send that JSON directly back from the Postgres, avoiding serialization, deserialization overhead at the GraphQL server as well. So this often results in a phenomenal speed up when paired with GraphQL query caching plus database query caching plus the pushdown approach results in a pretty phenomenal speed up. All right, next let's talk about data caching. So with data caching, the idea is to reduce your load on upstream services. So if you see 10K requests from the client, these are usually 10K requests to the database if you're fetching this data from a database. But the idea is to reduce that to maybe just 1,000 requests to the database, right? And effectively reduce your database. And this works well when you kind of identify hot queries, or queries that are the most kind of popular and are straining the system. And what you can do is cache the results instead of hitting the upstream system to compute those results. The trade-off here is that you have consistency problems and you might have stale results, right? Because you're caching that data outside the database, you're caching that outside a system that understands consistency. What that means is that you are going to have, for a brief period of time, while the data is cached, your data might be out of date. Data caching, unsurprisingly, is hard. And this is hard with GraphQL. This is hard for REST APIs as well. And automatically caching data that changes dynamically is painful for two reasons, right? The first problem that you want to solve is you need to understand what to cache, right? How do you cache data? How do you know what data to cache? This is, for example, let's say there are two users, user one and user two, and they both make an API call to fetch their profile. Now, the API call might be the same. If it's REST, it might be /profile. If it's a GraphQL query, it might be query profile. But the result that is fetched is entirely different because it depends on the identity of the user. So in this case, this API call can't be cached because the data set that is fetched is different. So knowing what to cache is hard because it depends on the identity of the user. The second problem is how do you update or invalidate the cache, right? Which is because it's dynamic data, how are you going to decide when you invalidate the cache and say that these results are stale? Let's fetch fresh results from the upstream data source. Let's take an example that we're going to use through understanding these various flavors of data caching. So let's say, for example, we have an API called that fetches restaurants, right? So I'm using a URL path here called /restaurants, and that turns out to be a surprising win for REST, right? It's like with REST, I can compress the information I need to show on a slide. With GraphQL, I would have had to show you the full query. REST 1, GraphQL 0. No, I'm joking. But if you have a restaurants API call and user one is making this API call to fetch restaurants on a restaurant listing app, and then you might have user ID 2, and then you might have user ID 3, right? So they're all kind of on their apps and they're fetching this restaurant data. Now, when you're trying to fetch this list, the code that you're executing is you first want to understand who user ID is, who this user is, where they're based. And if they're based in a particular city like San Francisco, you want to load the restaurant list for San Francisco, right? And so what you're probably going to do is go to a cache and fetch that list from a cache, right? Similarly, when user ID 2 comes in, you realize user ID 2 is in Dublin. And so you need to load the restaurant list from Dublin. And so maybe you have that entry in a cache. And so you fetch that data, right? User ID 3 is in San Francisco. Once you figure that out, you can now load that from the cache, right? So this information, even though the API call is the same, because these users are different and because there's a property of this user and a property of the data, you're going to use the cache in an appropriate way to fetch that data, right? The trick here is understanding how we're going to do this with GraphQL and how we're going to try to automate this. So let's talk about the second problem, which is how do we invalidate the cache. The first simple way of doing it is that you base it on time and you say, you know what, we're going to maintain this cache for 60 seconds because within 60 seconds, if there's an update, we don't care. It's fine. You can look at data that is stale by a minute and it's not going to destroy our users, right? And this is simple because you just have a TTL based cache, right? The other is kind of a more significant problem, which is that you track all of these update events that are happening to the system. You say, if there's, let's say, for example, there's a restaurant update operation that happens on restaurant 1, 2, 3. You need to figure out if it is a restaurant, if it is an update event that is going to impact your cache. So is this restaurant also SF restaurant? Is it going to impact this cache that I was using for the restaurant query? And if it is, what you do is you then go and invalidate the cache. This is an extremely hard problem. In the database world, this is often called the materialized view update problem, right? And updating a materialized view and doing this is non-trivial. It's in fact so hard that people often don't do this at all and just stick to time-based caching. And what they do is have maybe very specific cases where they have very specific events that can go update the cache, right? But it's a very hard and almost impossible to do with reasonable effort in a generic way, right? So those are kind of the two problems with caching, right? Now let's talk about 3 ways to cache data with GraphQL, right? So the first example is, or the first method is that we can say that we're going to cache data before before it even hits our GraphQL server or before it hits the GraphQL query processing pipeline, right? And so you can cache the data here, or you can cache the data inside resolvers, right, where those particular bits of the GraphQL query are being processed. And third is that you can integrate or automate caching so that the caching mechanism hooks in to the model level logic, which is integrated with the data fetching logic of that particular model. And so we look at all of these three approaches. So the first approach is we're going to cache it before it hits the GraphQL pipeline. Not necessarily before the GraphQL server, it might be in the same technical server, but what I mean here is before the GraphQL query is processed. This is kind of very similar to caching GET requests with a CDN, right? It's like saying you have an HTTP call, it makes a GET API call, and then you have a CDN that can cache that for some amount of time with a cache control header or something like that, right? And in this case, the server that is doing the caching or the bits of the server that is doing the caching does not really does the caching entirely automatically, right? It doesn't, the API server, the GraphQL API server doesn't really know anything about caching. So it's the caching happens entirely before that API logic runs, right? In this case, a rough algorithm, just to give you a sense of what this would look like, is something like saying that here there's an incoming GraphQL query. You look at the query's identifier, right? You see if this query is cacheable or not, because some queries are cacheable or not. Like, for example, if you know that it's a query that's fetching public data, it's a GraphQL query that is fetching data from is fetching data in a way that will not depend on the user's identity, right? You don't have to solve the what to cache problem. And then what you do is you load that data from a cache instead of running those resolvers. And of course, if you don't have that data in the cache, you populate the cache by running that query, right? The caveats here, as are obvious, is that this only works if the GraphQL query result doesn't depend on the identity of the user or a dynamic property of that request. It only depends on the GraphQL query that is coming in, and this works, for example, for public APIs or unauthenticated APIs, or perhaps more accurately, unauthorized APIs, right, where APIs don't have authorization. So just kind of taking a look at how this could work in our restaurant scenario. And again, apologies for using the REST way of displaying things. It's just a little bit easier. So if I have a restaurant, and instead of now making the list of restaurants that are fetched a property of the logic, what we can do is make it a property of the API call itself. And now what happens is that each of these API calls are cacheable by a system that's outside our GraphQL server because it doesn't depend on the user identity anymore, right? So we can say, hey, this is from the SF list, fetch from the cache. This is from the Dublin list, fetch from the Dublin cache. This is from the SF list again, fetch from the SF list, right? So our GraphQL system doesn't really have to do anything to process the GraphQL query. We know that we can just load it from the cache, right? Let's look at the second example, which is caching at GraphQL resolver level. And this is kind of more similar to if you were building your own API controllers with REST APIs, how you would cache them, right? Or how you would implement caching in that scenario. So here a rough algorithm would be that inside every resolver, depending on the logic, right? Depending on, is this public data? Does this depend on the user? Does this not depend on the user? You make that call as a developer because you have that information as a developer inside your mind, and you decide whether you can create a cache key and whether you can put this in a cache or whether you just have to query the upstream database, right? So you can make that call as the author of that resolver. And so whenever that you need to fetch that data, if you know that it's cacheable, you use the cache key and you load that data from a cache instead of loading it from the data source. And of course, you populate the cache if there's a miss, right? In this case, the caveat is that you have to hit the cache for every resolver, which means that you run into an n+1 kind of problem potentially again. That means your caching system also needs a data loader. And now you're just like, this is a lot of work, right? And especially if you realize that these multiple resolvers are fetching data from the same model, right? Maybe you have for example, with Relay, you have a top-level node interface, right? And you can query for any node using a GUID. Now, in this case, so there is some logic that is fetching that data for a node, but at the same time, you might have a GraphQL query, which somewhere deep inside the query is also fetching the same data from the node. So the data fetch logic for at the top-level node and the data fetch logic for a resolver that is deep inside the query, they are acting on the same model, but they're both implementing their own data fetching logic logic and their own caching logic, right? And so that code has to be duplicated, and you have to make sure that you're keeping both of those in sync as a developer as well. It's also hard to automate because this information is inside your mind, right? Only you know what can be cached. The system itself cannot kind of automatically cache it, right? At least in the previous system, we can identify that certain queries are just public APIs, and so we can just cache a bunch of them, right? But in this case, all of that burden is kind of on your shoulders as a developer. Let's take a look at what this looks like if you have a restaurant example, right? So in our restaurant example, we have, you make a query to restaurants, you run the restaurant resolver. The restaurant resolver knows that, this data set is dependent only on location. So it creates a cache key based on the location, right, which is San Francisco. And so it loads the San Francisco list, right? So you have that cache key information here. You use that cache key to load that from the cache. Similarly for Dublin, and similarly again for San Francisco, you load it from the same cache. So this resolver has the information about knowing what to cache and what that cache key is so that it can load from the cache, right? The third example that we're going to look at is caching using model level rules. So in this case, the first thing that we would do is that each model should have declarative authorization and relationship rules. So what you want to do is you don't want to write the code for understanding how to fetch data for a particular user. Instead of you writing that code, you load that from a internal kind of a configuration that you maintain, right? So you have these rules as JavaScript objects or as JSON objects that you specify and attach to each model. And so for example, that when I'm fetching restaurants, the rule here is to fetch the restaurant by user.location, right? So if you can represent that particular rule as a declarative configuration, as a piece of data and not as a piece of code, that becomes very useful because now you can use it to automate your caching logic. So the first requirement is that your rules that determine how a particular query or how a particular data fetch depends on the user that is kind of making that query, then you are able to convert that to data, and now we can use that in the future for automating caching. So now your resolvers that are fetching data don't actually fetch data directly from the data source. They fetch data from this kind of generic data fetching layer, right? And this data fetching layer that you have is automatically combining those declarative rules that you have when it's making the query. So now because you have a set of rules that are attached to the model, when your data fetch code is running the code to fetch the restaurant list, it's not just fetching the restaurant list, it's fetching the restaurant list and applying that rule, that fetch restaurant list where restaurant.location equal to current user.location, right? So you're able to, the data fetching logic can add that rule from that declarative map, right? You can do a lookup on the authorization rule list and apply that rule. The nice thing now here is that knowing this information of what to cache and whether the data set depends and whether the data fetch depends on the user identity or not is not at the resolver level, but it is in fact there in a piece of data, right? So before you run the resolver, you automatically know that this particular data fetch is not going to depend on the user identity at all, or if it depends on the user identity, you know how it depends on the user identity, right? And so now if you want to think about how to cache it, what you can do is when the GraphQL query comes in, you already know what the various models that are going to be hit are, right? Once you know all of the models that you can hit, and this is because you have the query cache, right, which you have the execution plan. The execution plan can tell you what are the different models that you're going to fetch from. Now that you know what the different models that you're going to fetch from, you know whether this entire fetch will require the user identity or will not require the user identity. If it doesn't require the user identity, it's like public data. You can load it from the cache without even thinking about it. If it does require user identity, you can determine if there is a key that can be extracted. For example, is it location? Is it a group, right? Is it an organization? Is there a property of this user that you can use as a cache key? Because you will notice that property is going to be in your declarative authorization rules, right? And so if the same query comes in for multiple user identities, you can see that those multiple user identities in fact have the same property, which will result in fetching the same data, right? So if you know that multiple users are coming in and it all depends on the user.location not location, then what you can say is that, well, I can use I can now, in fact, instead of making a 10,000 requests, these might just be 500 requests to the database or 500 unique fetches, because I know that it's only 500 unique locations across these 10,000 users, right? So let's take a look at our restaurants example. In this case, what we're going to do is when this query comes in, we're going to, before we run this query, before we start kind of making those data fetches, what we can do is we know what property these data fetches are going to depend on, right? And we know that this property is going to be location, because we can process the authorization rules that we have, which are just data. So we can go through those authorization rules. We know that this entire data fetch is going to depend only on location. So now you can take that location and make it a cache key. So that location and the query, location comma query, becomes, or location comma restaurants query, that becomes the cache key. And now you load it from the cache, right? Or you populate the cache and then you load it from the cache. And similarly, when the query comes in, when the same query comes in for a user that's now in Dublin, you create a new cache key that is the new location, which is Dublin, and then load it, populate the Dublin cache and load from the Dublin cache. And now when a repeated query comes in from a completely different user that happens to be in the same location, because you're going to use the same SF comma query or location comma query as the cache key, when you hit the cache, you're going to get a cache hit, and you're going to be able to load it from this previously populated cache that you already had, right? So the cache key is kind of automatically able to include the user's group, and we got this ability, right? We got this ability to automate things because we made the rules of how that data fetch happen declarative, and that allows us to can cache the entire query. Right. So this is in fact the approach that we use on Hasura Cloud, and we have an LRU cache that caches the most popular queries and evicts older queries. We use a cache directive, and so that means that the client can control the tolerance for their stale data, and of course you can use an allow list as well to make sure that clients just don't decide to arbitrarily cache all the data that they receive. And Hasura Cloud then uses a combination of that first strategy of knowing that, if the query is independent of the user identity, that it can just load that from a cache. And if it is dependent on the user identity and the data is coming in from a database, Hasura Cloud can determine what that unique group is and whether there is a unique group across these queries, and then use that group as a cache key, right? And all of this obviously happens because while you're using Hasura, you're able to represent all of these data fetching authorization rules, right, declaratively, and that is the reason why this automation can be unlocked. All right, so do check it out on hasura.io/cloud. Let me know what you think, and happy to discuss caching. Please feel free to hit me up on Twitter or reach to me on LinkedIn or Twitter, and we can talk about all things caching, GraphQL, and Hasura. Have a fun GraphQL Summit conference. See you in the conference and see you in Discord.
Hey folks, hope you enjoyed the talk. I'm going to be taking some questions now. Feel free to pop in on the Discord channel that says questions for speaker, and feel free to post in your questions there, and we can talk about them. I think I'll take the first question, which was what are the biggest differences between caching public and private APIs? No, it's part of kind of what I talked about, which is I think the idea of whether you can share data or not, right? That's kind of really where caching becomes effective across requests, right? Is can for the same request, can I serve the same page or serve the same data, right? If you think about a static website, it's like the same web page that you're serving for multiple people. If it's an API call, you're serving the same data for many people, right? So especially if it's like a public data set kind of an app, like you have public data that you're giving to people, then that is what I would call kind of a public API. And a private API is something that depends uniquely on the property of, or depends on some property of the user, right? And then private APIs can also kind of deal with shared data. And so this is when you have a user group and a group of users share the same data. In the example I was talking about, like with restaurants, or location is kind of their shared group. If you like, maybe it's a Google Doc, it's like your organization or your the document editor group is the shared group, right? And so that's kind of what a private API is. But private APIs can also kind of be sometimes transactional APIs. And transactional APIs, for example, can't be cached because it depends on it depends not only on the property of the user, but it depends on a property of the variable that will never be the same for anybody else, right? So it's like I'm making a payment transaction, but that transaction ID is different for everybody. And so we can, even though it's a private API, we can never cache this data. There's pointless caching this data. So that's kind of the main difference between public and private APIs when I was talking about that. Are there ways to define timeframes for automating caching? Example, you have this is a question from Kurt. Are there timeframes to define automated caching? For example, I have some things that you need to update quickly and other data points that won't change much. So that's a good question. It depends on your caching implementation, right? So for example, for each kind of query that you're caching, you can define your TTL, right? And again, it depends on what kind of caching you're doing. So for example, if you're building your own cache layer and you're going to cache certain queries or resolvers or entire data fetches in a cache, then what you want to do is you want to define a TTL there, right, for that, and that kind of depends on you, right? And you can decide to make that call yourself as the person that's implementing the GraphQL API, or you can also decide to give that control to the client and let them deal with the fact that they can decide whether this data is fast changing or the end user can tolerate the amount of staleness that they can tolerate. And I'm going to answer another question from Kurt that came in a little bit later. How should I configure relationships and auth on models? Is this something I do with directives or in a UI? So actually, I think this question might have. I think there are two elements to this question, right? It depends on like what you do with Hasura versus what you would do yourself. So if you're building this yourself, and my kind of intention behind this talk was to share kind of some of the strategies that we've been using at Hasura that you can also build yourself. You would have to set up your own system. Right, you would have to set up your own way the way that you're building your GraphQL server itself, the way you're setting up your models and the data fetching of the models and stuff like that. If you are able to do that in a way that is as declarative as possible, right? The models that you're defining and the relationships that you're defining, and it's basically code for you, right? Like imagine that you're able to define it in JSON. If you're able to define that in JSON and then use that to build the GraphQL server, then what you can do is you can introspect that JSON. Right, you can query that JSON to get information out of that JSON, and then use that for whatever you want to use it for, whether it's coming up with a cache plan or whether it's deciding what to cache and stuff like that. On Hasura, this is what we do internally, and so on Hasura, you see that everything is declarative. You use a UI for doing it. You can write a JSON configuration for doing it, but that information being introspectable, that information about authorization and relationships being something that you can analyze is very important, because then you can start thinking about automating it or creating a framework of automation for the developers, right? I'll move to the next question, which is is it possible to build purely declarative caching rules even for cyclical data sources? Do we almost end up needing some non-declarative escape hash? This is a question from Sean. I think it's a good question. I'm not sure. It's a very good question. I'm not sure how to answer it. I think I'm not sure I understand why, even if you have a cyclical data source, a declarative caching rule wouldn't suffice. But I have to think about that. I think I think if you're looking at automating things or providing some kind of automation to developers who are building their server or using a service, it has to be some element of being declarative, because only then is it easy for automation to kick in. But it's a good question. I apologize, I don't have a very good answer to it right now, but I'll think about it. I think some two other quick questions. If most of your data is dependent on the user identity, what's a good place to start with server-side caching in GraphQL? It's a very good question. Basically, you have to kind of set up this declarative framework yourself. Of course, if you're using something like Postgres or a database and you have a existing data source, then you should check Hasura out and see what that experience feels like, and see if that's something that you can take some ideas from there and bring that to your GraphQL service. The last quick question I will answer is, how does CQRS help simplify caching with GraphQL? That's a question from Khalid. That's a really good question. I think CQRS drastically helps us simplify caching with GraphQL because it's a mental model that forces you to separate your writes from your reads, right? And so in a CQRS style, you're thinking of like commands or events or mutations or query commands that are operating on data that go and update read models and read models are things that you're reading from. Now, when you start thinking of your world as read models or as projected models, right? What you start doing is you try to reduce the amount of transformation that you do while reading. You try to increase. So you try the amount of code that you have that's transforming data after it is being read is reduced because the data is already projected, and that makes it much easier to specify declarative rules for caching that depend on even user identity and stuff like that. If you're reading from these projected models, so if you start thinking about your backend as a CQRS kind of backend, the ability to kind of cache and the ability to create a framework to say this is how we're going to deal with our projected models, and your ability to start making things more declarative, right, becomes greater. So you can create an internal library or an API or a declarative rule system that you can give to your developers because now you have a projected model that you're going to use, right? So CQRS does actually help simplify caching with GraphQL a lot. That's a great question. There are a bunch of other questions which we can take later, but thank you so much, folks. I'll be hanging around on the Discord channels for caching in GraphQL. And so see you folks there for more questions. Bye.